Hello dear students, I Ganesh welcome all of you to this session of plus 2 second year mathematics, and today we have to go for a discussion on the topic relation and function. Already in our previous classes we discussed about the introductory concept of a function, and we are discussing how many functions are there. Already those things we are covered in our previous classes, and we are discussing on the types of function, where we have discussed about the one function, onto function, and its both property, that is both bijective or not. All these things are covered in our previous class. Now we are moving to an interesting concept of function, that is called as inverse of a function. So actually today's discussion is on the topic inverse of a function. So that is our point of discussion, inverse of a function. Okay. So in inverse of a function, first of all, I am going to clear from your mind, inverse does not means the multiplicative inverse. Okay. That does not means every inverse of a function. As we are from our childhood, there is a memory, or we are thinking that inverse means, for example, inverse of 5, we are telling it as 1 by 5. Okay, that is the multiplicative inverse. But every function cannot be written as like that. So today we have to discuss what the inverse means. So let us begin with the concept, what we mean by inverse of a function, and later on we will proceed from time to time that what are its other properties. So let us begin with the inverse of a function. Suppose a function f is defined from set A to set B, okay, where set with some condition where f of x equal to x square, and let A equal to 1, 2, 3. Okay, and if we go for the pictorial representation, you see that it is the set A, okay, and let it is set B. So you see there is 1, 2, 3 is there, okay, and the condition f is defined from A to B as f of x equals to x square. So if I give these inputs, so what are the outputs I obtain? The outputs I obtain as f of x equal to x square. So in this way, 1 has the output itself, 1 square, which is equal to 1. Now 2 square has the output 4, 3 square has the output 9. It may have some other elements, the set B, the codomain set may have some other elements. Let us take some simple example, that in this way these elements of the domain set are converting to their images, to their functional values, as one is converting, as per the rule x square, it is converting to 1, 2 is converting to 4, and 3 is converting to 9. Okay, now you see what the inverse means. This is the function we define, f of x equal to x square. Now somebody think in our mind that is there a rule to find the pre-image values of their image values, or what I am telling again, I am repeating, is there a rule to find those image values, to find the pre-image value of those image values. Okay, एटी जो image value जाको अच्छी, that is 1, 4 and 9, is it possible to convert them to their previous value, to their original value, to their pre-image value? So the rule, which again takes the elements of the codomain set to their original representation, that is called as inverse of a function. That rule, that technique is called as inverse of a function, or we can say it is a inverse of a function is a reverse process. It is a reverse process. As we are moving from one station to another, now we are returning to our original place. So that is a reverse process. Okay. So my dear students, inverse does not keep in your mind that inverse means it is a multiplicative inverse. Okay. So what inverse means? Inverse means it is a reverse process. Clear, my dear students? So we will move now we are understanding this concept of inverse as a reverse process. Okay. So what I will do, I am again going to clarify the thing with some of the pictorial representation. किछि pictorial representation रे आमे वर्तमान फर्दर इनवर्स उपरे concept टा क्लियर करिबा. ओके. यू सी वर्तमान पर्यंत आमे जानिले inverse is a reverse process. Okay. And the inverse is taking the image values or converting the image values to their original pre-image value. That is the condition, that is the process, that is the reverse process which converts the image values to their pre-image value, to their original value. Okay. In this way the function is defined, which is called as the inverse function. आमे सेही function को inverse function बोली कहिबा. Okay. Now we are going to clarify this one with some example. You see, suppose I have a function is defined. I have some pictures. It is a and b. So this concept is to show you when we will get the inverse of a function. You see, suppose I am showing it in a pictorial mode. Okay. Suppose these elements are converting like this. Okay. So this is the way f is a function defined from set A to set B, or it converts the elements. Now suppose it is the picture 1. Suppose I have a picture 2. F is the function which is defined, which is converting the elements. I am showing the elements in a dotted manner for your clarification. Okay. You see, now suppose this is the picture 2. Now we are going for picture 3. You see, let the function is defined from A to B. Okay, so these three pictures are there, and we will see when and where the inverse process means the inverse function of these functions in picture 1, in picture 2 and in picture 3 can be defined. Okay, in picture 3 can be defined. This type of pictures can be defined. Yes or no? So for your clarity, I am showing it. The picture 3 can be represented. I am showing it in the upper side of the board. Okay, you see I am showing it here. Suppose this is set A and this is set B. And suppose f is the function from A to B. I am showing it here. Okay, you see, suppose this is the conversion. This is the function is defined which converts the elements. Okay, f is converting. Now I have three pictures, the picture 1, picture 2 and picture 3. Okay, you see, in these pictures when and where we will get the inverse function. आमे inverse function केते बेले पाइबा. Okay, so we are going to discuss that one. You see here in picture 1, you see these elements are having their pre-images. having their images, and now it is satisfying the condition of the functions. So my dear students, remember or try to recall what are the conditions of a function. Function heba pai condition kon thila? That means all elements, if f is from a to b, all elements of set A are involved in it. So you see, all elements of set A are having their image values. Next, every element of set A have a unique image. Okay, but you see, when I am going for the reverse process, I am going to find the inverse function. If f is from a to b, the inverse function is from b to a, means it is the reverse condition. Yes or no? So here you see whether this function, this reverse process, this inverse function is existing. Let us see. You see, this one has a pre-image undoubtedly, but you see this element, this image element have two images, but this violates the condition of the function, existence of the function, because every element should have a unique image. So when I am going to find the inverse function, you see this image element have two pre-images, which is violating the nature. So this one is not considerable. This function does not have a inverse. Okay. Now we are moving to this one. Is it have a inverse? You see in this picture, in this diagram, you see these elements are present on A and these elements are present on B, and f is the function from set A to set B. You can see these elements are mapped. Yes or no? Now you see the condition of function is satisfying or not. The original function f is satisfying all its condition, as all elements of domain set are mapped. Next of all, every element has a unique image. Now, is there the inverse can exist? You see, yes, you can see the inverse can exist at here. Eti inverse भी हमें पाई परिबा. काहेकि ना एठी, if you go for the recall that the conditions of a function, you see all elements of the codomain set are involved if we are going for the inverse function. Okay, or we are going for, we can say, the reverse process. All elements are involved, all elements are mapped from B to A. Yes or no? Next of all, every element have a unique pre-image in set A. Okay, so this condition says that inverse function can exist at here. Okay, now we are moving to picture 3. Is it satisfying the condition of a function? Yes, it satisfies the condition of a function. Is it satisfies for the inverse function? Is this picture can be possible? Can we find the inverse function at here? You see carefully. Yes, my dear students, we can't find the inverse function. Why? Because it violates the first law. As f is from A to B, the inverse should be from B to A. But all elements of B are not have their pre-images, or we can say that codomain is not equal to the range. So here you see this one has a pre-image, this one has a pre-image, this one has a pre-image. But what about this element? Is this element that this element does not have a pre-image? Okay, that's why this condition, this function does not have a inverse function. So my dear students, it is on the discussion that every function does not have a inverse. So my question is, which function has a inverse? Kaharo inverse thibo? Please look carefully and tell me. Look carefully. Yes, my dear students, your imagination is correct. That the original function should be bijective in nature. Bijective ହେଇଥିବାକୁ ପଡ଼ିବ, means it is 1 1 and onto see 1 1 भी ହେଇଥିବ and see 1 2 भी ହେଇଥିବ, then only we can find the inverse of the function, otherwise not. So that's why as this picture is only satisfying the 1 1 condition, this and the onto condition, so this function is having inverse, but these two pictures are not satisfying the nature of the 1 1 condition, or the codomain is equal to the range set which is the onto condition. So these two pictures are does not having the inverse. Okay, so original function should be bijective. If f from a to b is a bijective function, then only its inverse can be found, otherwise not. Then only the reverse process can be found. Okay, with this we are giving or trying to give some of the introductory concept on the inverse of a function. You see, yes or no, my dear students? So what we discuss, let us go for the definition and the procedure to find the inverse of a function, to find the rule, to find the technique to get the original pre-image elements. Okay, so I am going to write the definition now and then we will proceed for the procedure, okay, to find the inverse of a function, and later on we will discuss on some of its properties. So my dear students, please make note of all those things. Okay, watch those videos and also make a note of the important things for your clarity. Okay, so we are going for the definition now. So say I am going to write the definition. Let a and b are any two non-empty sets. Any two non-empty sets means set A and set B are having some elements. Okay, consider what f from A to B. So f is the function defined from set A to set B be a bijection, means it is bijective in nature, otherwise the inverse cannot be found. Okay, as we see through some pictorial mode that inverse, for the existence of inverse, the original function should be bijective in nature. We want to find a rule what the inverse means. We want to find a rule which, so the rule, what the rule do, which is converting the elements of the range set to their pre-image value. Okay, which enables to convert all elements of B, which converts all elements of B to their pre-images. Means whatever present at there, that will convert to their pre-image. Okay, let G is from B to A. Suppose that rule is defined as G from B to A be a function. Let G is from B to A be a function which is able to convert all elements of B all elements of B to their pre-image elements, to their pre-image elements H as x belongs to A implies f of x equal to y belongs to B, then y belongs to B implies g of y equal to x belongs to A. Okay, so you see what the function g do. The function g is converting all the image elements to their original form. Okay, hence if this is the case, hence g is called as, so that means we have to find that rule g. Okay, hence g is called as inverse function of f. G is called as inverse function of f. Okay, and it is inverse function of f and denoted as f inverse. So you see it is the inverse function of f denoted as. So you see here that the inverse function of f is denoted as f inverse. Okay, it is just a representation. We are reading it as f inverse, but that does not imply that is a rule only. That does not imply it is the multiplicative inverse. That is why I am writing. Okay, remember what? F inverse is not equal to 1 by f. Okay, it is not always equal to 1 by f. That type of thinking is a wrong one. So my point of view is, or make a note, please make a note, what? F inverse is not always equal to 1 by f. Okay, maybe in some cases it can be represented like that, but it is if you think that always f inverse is equal to 1 by that value, or it is the multiplicative of the original function, so my dear students, that is not possible. That is a foolish thinking. Okay, so don't think like that. It is just a representation. It is a reverse process. Okay, so this is some of the definition of inverse function. Now we are going to go for the rule to find the inverse of a function with some examples. Okay, please make a note of it. Then we will proceed for some rule to find the inverse of a function. Okay, so we are going to write the working rule. So this is the definition of the inverse function, and later on we will go for the properties. So next we will proceed to see working rule. To find what working rules means. What working rule means? The procedure adopted to find the inverse of a function. If a function is defined, then which is obviously which is bijective in nature, or we have to check it whether it is bijective or not. If it is given that check inverse exists or not, means first of all we are going to check that it is bijective. The original function is bijective or not. Bijective means what? It should be 1 1, it should be on 2. Okay, so if it is bijective in nature, then only inverse function can be exist. Okay, so my dear students, to find the inverse function or to check the inverse function, we have to check the original function is bijective or not. So now we are going to write a rule or the procedure adopted. How do we proceed to find the inverse of a function? गोटे फंक्शन रो इनवर्स किपरि आसीबो फंक्शन डिफाइन हेतिबो आमानक बुक रे विभिन्न प्रकार क्वेश्चन अछि टू फाइंड दी और टू एग्जामिन दी इनवर्स फंक्शन ओके सो आमे वर्तमान देखिबा इनवर्स फंक्शन केमिति एक्जिस्ट हबो ओके सो आवर प्रोसीजर इज वर्किंग रूल टू फाइंड दी inverse of a function. So the rule adopted, what we should adopt to find the inverse of a function. So it says let f, so for it what the original function is given, let f from a to b be a bijection. Let f from a to b be a bijection. Then to find f inverse, from b to a, from set b to set a, steps followed are step 1. What are the steps we put to get the original value? Okay, so what the rule says, put f of x equal to y. That means the given f of x first of all should be denoted as y. आमे f of x को कौन बोली डिनोट करिबा, y बोली डिनोट करिबा, where x belongs to a to the domain set and y is belonging to where, y is belonging to the codomain set or you can say range set as it is a bijective. Okay, so next what we do, next step 2. So first of all we should represent it as y. Next is solve f of x equal to y. Solve f of x equal to y. Find the value of x. Find the, so put f of x equal to y and after it solve it and find the value of x in terms of y. So this is the second step. Okay, so that means we have to solve it and we have to write x in terms of y. Next, the third step and the last and final step is the value defined as for x in step 2. So the value obtained in step 2 is the value of f inverse y. Okay, so this is the procedure obtained to find the inverse of a function. These are the steps obtained to find the inverse of a function. Now we are going to show it. We are going to find the inverse function as per the procedure with some examples. Okay, so we will proceed with the example. So please make a note that how to find the inverse of a function. I write in detail about to find the inverse of a function. Okay, now we will proceed to find with the example. Okay, what type of examples given, what type of problems are there, let us discuss it with a problem. Okay, now we will go with the example. The question is given as so that f is a function which is defined from r difference 3 by 5 to r difference 3 by 5 as f of x equal to f of x equals to 3x plus 2 by 5x minus 3 is invertible. So what the meaning of invertible? Invertible means the original function is existing and its inverse can be found. Inverse, f inverse or the reverse process can be found. So those functions are having inverse. They are called as invertible. So first of all we have to show that it is invertible. And when it is invertible, that when it is bijective in nature. So when it is given to show it is invertible, we have to show it is bijective in nature, is invertible. And next, find f inverse if possible. Find f inverse if possible. So in this way we have to find the inverse of a function. Okay. So this is the one of the example to find the inverse of a function. Let us go in detail to find the inverse of the function. How to find the inverse now? Okay, so we are writing the solution. Clear? We are going for the solution. You see, given f is from r difference 3 by 5 to r difference 3 by 5 as f of x equals to 3x plus 2 divided on 5x minus 3. Okay, so this is given. We have to show f is invertible. So for it, what we have to do? We have to check the 1-1 condition and we have to check the on-2 condition. Yes or no? That means f is bijective or not. So clear? So for it, we will go for one by one. So the steps we are going for to check the 1-1 condition. Okay, the function, original function f is 1-1 or not. Because if it does not satisfy any one of the condition, then we can't say it is invertible. So for existence of inverse, it should be what? It should be 1-1. It should be on 2. Okay. So what we do? We are taking the 1-1 condition. So for it we will take the elements. Let x1 and x2, two different elements. Okay. Let x1 and x2 belonging to this domain set are difference 3 by 5. As we know for how to check the 1-1 condition. Okay. Then find f of x1. Here f of x1 is what? F of x1 equal to 3x1 on plus 2 divided by 5x1 minus 3. And also find what is f of x2? F of x2 is 3x2 plus 2 divided on 5x2 minus 3. Clear? So that is f of x1 and f of x2. Then consider, this is the way to find, to check it is 1-1 or not. We already discussed in our previous classes. Consider f of x1 equal to f of x2. Okay, that we have to consider. And what it means? It means 3x1 plus 2 divided on 5x1 minus 3 is equal to 3x2 plus 2 divided on 5x2 minus 3. Clear? Okay. Now I am erasing some portion. Okay, and I will proceed. Then you see, you please make a note of those things. Okay, these are very important for your exam point of view. Okay, my dear students, what we obtain? F of x1 is equal to f of x2. So we are at here. Now what we do? We are going to show that x1 is equal to x2 or not. So for it, we are solving it and now we are going to solve it. You see what we obtained? We obtained on cross multiplication, we obtained 3x1 plus 2 multiplied by 5x2 minus 3 is equals to 5x1 minus 3 multiplied by 3x2 plus 2. So on cross multiplication, you see what we obtained. It is 15x1 x2 minus 9x1 plus 10x2 minus 6 equal to, on this side it is 15x1 x2 plus 10x1 minus 9x2 minus 6. So this is the result we obtained. Now cancelling the common terms, this one is cancelled with this one is cancelled with this one. Again, on taking the values to one side, what we obtained, that 19x1 is equal to 19x2, or you can see x1 is x2. Yes or no? x1 is x2. x1 ର value କାହା ସହିତ equal ହେଇଗଲା ନା x2 ସହିତ equal ହେଲା. So this function is 1 in nature, that we are sure now. Okay, therefore f is what? 1. Clear? Okay, now I am cleaning this one. So this function is 1 in nature. Now for next, what do we have to do? We are going to verify whether it satisfies the onto property or not. It satisfies the onto condition or not. Okay. So next we will go for the what? Onto property, or onto. We have to check the onto condition is satisfied by this function or not. So for it, what we do? Let y belongs to. We have to take y where? We have to take y in the codomain set. So what is the codomain set? Let y, that codomain set is defined as per the previously we write it here. What is the codomain set? It is R difference 3 by 5. Okay, that is the codomain set. So let y equals to R difference 3 by 5, and consider f of x equal to y. So we have to consider f of x as y. So what is our f of x? That implies the f of x is defined as 3x plus 2 divided on 5x minus 3. So that is considered as y. Now in onto function, what do we do? We have to solve it and we have to find the value of x in terms of y. Okay. So for it, I keep 3x plus 2 as it is, and I am going to make the cross multiplication. This portion, the denominator, is going to multiply on that side. So what do I obtain? 5xy minus 3y. Yes or no? It is multiplied as 5xy minus 3y. So you see, now I am going to express x in terms of y. So what I do? I keep those x in one side and I am taking the others to the other side. Okay. So that implies 3x minus 5xy equal to minus 3y minus 2. And taking x as common, it is 3 minus 5y is minus 3y minus 2. Or I can say x is equal to, taking it is minus 3y minus 2 by 3 minus 5y, or we can say by taking a common of minus on both numerator and denominator and cancelling it, it is 2 plus 3y by 5 minus 5y minus 3. Okay. So this is the way to find the value of x. This is the value of x. Okay. So you see, now we can check that for all y belongs to there, whatever the y you put from this set, from the real number except 3 by 5, we will get a x, and this can be evaluated. Okay, so we can say therefore for all y belonging to R difference 3 by 5, there exists x belonging to R difference 3 by 5 such that f of x equals to y. Therefore, what we can say? Therefore, f is onto. So, we obtain f is onto. Okay. So, we can say, therefore, now I am going to clean this one. Okay. So, now what we do? We have obtained the condition, or we have verified that f is both 1 1 and f is both onto in nature. Yes or no? So we can say, therefore f is both 1 1 and onto. So that is, if it is 1 1 and onto, so what we can say? That is, it is bijective in nature. F is what? F is bijective in nature. Therefore, f is invertible. That's why we can say f is invertible. Otherwise, we can't say. So, my dear students, it is very vital that when we are going to check inverse or not, first of all, we are going to check f is existing or not and f is bijective or not. Okay. For existence of inverse, f should be what? F should be bijective. Otherwise, its inverse cannot be found. Okay. So here f is invertible. Okay. Now, how to express that inverse function? Okay. So we can say, therefore f inverse y, which is equal to x, is 3y plus 2 divided on 5y minus 3. Okay. So our inverse function is from B to from here the codomain set to the domain set is f inverse of y equal to 3y plus 2 by 5y minus 3, or by changing variable, therefore f inverse x equal to 3x plus 2 by 5x minus 3. We can put any variable. Okay, as generally we are putting x, that's why I am writing converting x, okay, in format of x. You can convert in some other format also. So generally we are writing, as we are obtaining now our inverse function, so we are just changing the parameter in type into format of x. So this is the way to find what? To find the inverse function. So here now this is the f inverse, or the inverse is existing. So in this way, my dear students, you can find the inverse of a function. So this type of examples, this type of questions are in your books also. You can go through them and you can check whether the functions are invertible or not. If the functions are invertible, then it is you should go for the checking that you should go for the verification whether the functions are bijective or not. If original functions are bijective, then only inverse can be found. Okay. So it is a important question. So go through it. Okay. Next, what we do? Next, we will go for the some of the important results. Okay, and try to verify them. Okay. So now I am cleaning the board. Okay. Now we will go for the some of the important concepts. So next, some important results. Okay. So what are the results we can observe in our inverse functions? Okay, that we are going to discuss one by 1. The first result says, or the some of the important property says, if from f is from a to b, if f is a function defined from a to b, is a bijection, then f inverse, which is defined from b to a, at that time, if it is a bijection, then obviously we can find the inverse function, which is a reverse process from where to where? From b to a. Okay, is also a bijection. That is very important. Okay, this result is very important. Let us prove it. Let us prove this result, that if f is a bijective, then its inverse function is also bijective in nature. Say inverse function na madhya kon hobo? Bijective hobo. Let us go for the proof. So we are going to prove it. So given, what is given? F is from a to b is a bijection. So what bijection means? I am writing here 1 1 and on 2. Both the conditions are satisfied by the original function f. So now we have to show. What we have to show? F inverse from b to a. F inverse from b to a. Now f inverse is defined in what type of manner? Such that f inverse y equal to x. So my dear students, if f inverse y is x, what is x and what is y? Where y belongs to b and x belongs to a. Okay, is also what? Is also a bijection. Is also a bijection. So for it to show it as a bijection, okay, now we have to show it through its properties, that it is 1 1 and it is on 2. Okay, so now we are going to show that it is 1 1 in nature. To verify, so we are going for the what condition? We are going for the 1 1 condition, and we check whether the function is 1 1 or not. The reverse process, the inverse function is 1 1 or not. For it, what we do? We take any elements y1 and y2 belonging to b, any two elements. So if these are belonging to b, their images are belonging to where? Their images are belonging to set A, where f inverse y1 is equal to x1 and f inverse y2 is equal to x2. Okay, so I am writing in a correct manner as we have defined it. Now what we do? Consider f inverse y1 equal to f inverse y2. That implies what we obtain? x1 equals to x2. That implies what we can say? F of x1. If I apply the function f on both sides, on both the elements, why we can write like this from x1 equal to x2? That implies since f is 1 1 and also on 2. So if x1 equals to x2, we know the original function f is bijective, that is given. So f of x1 can be written as f of x2. And what is f of x1? It is y1 equal to y2. So you see, my dear students, what we take? Therefore f inverse y1, we take f inverse y1 equal to f inverse y2, and we obtained y1 is equal to y2. So if the images are equal, the original elements are also equal. So this is the condition of the 1 1. So we can say, therefore f inverse is what? is 1 1 in nature. Okay, so we can say F inverse is 1 1. Now we can move for the onto condition. Okay, I am cleaning this one. We will go for the onto condition. Please make a note of those things. Those are very important results, or you can say very important properties also. Okay, so please make a note of those things. Those are very important. So now we are going forward. We are going to show onto, or we are going to show that F inverse is what F inverse is onto in nature. That we are going to show. How? For it, what we do? Let x belongs to A. Be any element. We are taking a element x belongs to which is belonging to A, and we have to show that every element has its what? Pre-image. Okay, then f of x equal to y belonging to B. Since original function is it is bijective in nature, so we can write f of x equal to y. If x is belonging to A, f of x equal to y undoubtedly. That implies f inverse y is belonging to where? It is belonging to, it is equals to x. Okay. Hence we can say therefore f inverse is what? Onto. Because for all y belongs to B, we get x belonging to A. So we can say f inverse is onto. Therefore f inverse is what? 1 1 and onto. Both the conditions are satisfied. So we can say f inverse is what? F inverse is bijective. F inverse is bijective in nature, or f inverse is a bijection. Okay, so this is one of the important property of bijection. Okay, my dear students. So I am cleaning this one. Next we are going for another property. Okay, what the property says that f inverse operated on f is a identity function on A, and f inverse operated on f is a identity function on A. Okay, so next property is property number 2. So we can say the property or the result 2 is f inverse operated on f is an identity on A, and f operated on f inverse is an identity on B. Okay, this is one of the important property. Next, some of the other properties are, so this is property 1. Next, property 2 is inverse of the inverse is the original function. Okay, so these two are very important properties for you. So please make them as a note. Okay, so my dear students, today we discuss about the inverse of a function. Okay, and we see what is the meaning of inverse, how to find the inverse of a function, and what are the properties involved in the inverse of a function. Okay, so with this we rest here and we will proceed to some other portion of function in our next class. Okay, so till then, goodbye and thank you to all. Okay, bye.